Hello everyone and welcome to my new channel The World in 15 Minutes. And yes, I know, such an original name. You are probably thinking, oh great, another talking head in a cap who's about to lecture us with a serious face about how ChatGPT works. And you know what? You're absolutely right. A talking head, a cap, but please, give me 15 minutes and I'll do my best to convince you that you actually enjoy my content. Ready? Let's go. Let's start with a concept. For our video, we'll need a model, a server and a client. Our client will send a request to the server will connect to the model will process this request, and the server will send a process response back to the client. Now let's break down what we need for our server or client and which model we'll be using. For our model, we'll use the Hugging Face platform. We'll download a model from this resource, then create our own directory on Hugging Face and upload the models that we downloaded to our local machine. I've already found a suitable model for you. It weighs around 16-17 GB and fully meets our requirements. We'll load this model into our workspace. Why we are doing this? So that in the future only we have access to this model. For our server, we will need the Python programming language and a tool to create a container, Docker. We'll create a Python script where we will use transformers library to connect to our model. We also use FastAPI to launch our server. After that, we'll create a Docker container and then upload it to Docker Hub. Then we'll move to Paperspace, where we will set up our server and deploy the containers that we previously uploaded to Docker Hub. As for the client, we'll need JavaScript and a tool called Cursor AI. For those unfamiliar, Cursor AI is a fork of Visual Studio Code with a built-in AI assistant. Using this AI assistant will generate the client-side code committed to GitHub and then deploy it from GitHub to Railway.app. Now, for the final result, in the end, we'll have a public link that anyone can use to interact with our AI model and ask it anything they want. All the links to the resources as well as the complete code will be available in the description of this video. And one more note, I've already registered on all the necessary platforms, so I won't be showing the registration process, but I believe in most cases it's pretty intuitive. So in the end, we'll build a complete infrastructure that will be fully under our control, all for just $1 per hour. And pay attention, in just 15 minutes. So, are you ready to give a try? Let's go! As I mentioned, first we go to the Hugging Face platform, sign up and follow the link. All the links will be in the description. We need to find this model, internal MB instruct. Then we go to the Files and Versions section and download all the files of this model. This is very simple, just click on the downward arrow to download them. All these files will be saved to our local machine. I've already done this. After that, we go back to Hugging Face, sign in and add a new model. Once you've added a new model, you name it, I named mine test, and then upload all the files from the model just downloaded to your local machine. This way, your directory will contain your complete model. The only thing left to do at this step is to copy the path to the directory so we can process this further. Now let's do it. Alright, now let's move on to our server setup. We open Cursor AI, but you can use any other code editor. The AI component is not required for this task. All 4 files will be available in the GitHub link in the description. So let's now understand the files. As I mentioned, let's start with the API Python file. The only thing you need to change here is to copy and paste the link to your model. That's it. That is the one we just copied from Hugging Face. We paste it here. You don't need to modify anything else. This code is taken directly from the models page on Hugging Face, including all the default settings. That's why you can see English text, Chinese characters, etc. I didn't modify much, just adapted it slightly to run our own server. Here you can see that we are using the transformers library to launch our model. Then we use FastAPI to set up our server. By making a post request to the generate endpoint, we send a request to the model, it processes it and returns a response. As for the Docker file, next, you'll need a Docker file. In the Docker file, you can see that it downloads a standard Python image, installs all required libraries, creates a working directory, copies the necessary files, installs dependencies, and opens the required port before launching the server. Requirements files. In the requirements file, we list all the necessary libraries. Now we need to build our Docker image using the following command. Docker build t-my-image. Once the image is built, we need to tag it. You can use the follow command to tag it. Docker take my image, my Docker Hub repo, my image. Then we push the image to Docker Hub with this command, Docker push to my Docker Hub repo. I've already done this, and as you can see, the image is uploaded to our Docker Hub repository. So now let's go to deploy on Paperspace. And now we move to Paperspace to deploy our server. Let's start. We go to deployments, create a new deployment and select the type of machine. You need CPU or GPU. It's important you see here CPU or GPU. It's important to choose a GPU because our model requires GPU resources. The CPU is not sufficient. Ideally, we should use a P6000 which costs around $1 per hour. However, this option is currently unavailable. So we can choose an A5000 instead. Alternatively, you can wait few hours for the P6000 to become available. The key requirements is that your server must have at least 24 GB of GPU memory, otherwise the model will not run. So now let's go to final configuration. Once you've selected the server, scroll down, enter a name and paste the directory where you uploaded your Docker image in Docker Hub. Additionally, you need to add the following command to specify the port. In our Docker file, we open port 8000, but the default port here is 80. So we either run the container on port 80 or modify the Docker file to expose port 80 instead of 8000. Once everything is set up, click deploy. Within 2-3 minutes, the deployment will be complete and you'll see logs confirming that the model has loaded successfully. You should see a log with something like, in my case, Oleg test for my model. This means the model has been fully loaded into the server's memory and is running. Now, and final step, if you can see a message saying we are running on this port, then the server has successfully started. Now just copy the endpoints and this will be actually your server URL. Alright, now let's move on the final part, setting up our client. We open Cursor AI again, and in this part we will actually need the AI assistant. First we create a new folder. You can name it whatever you like. I name mine frontend. Then we run the following command, npx create next app latest. This command creates a new Next.js project. Press enter and the project will start generating. Once the installation is complete, we copy our prompt into the chat. The prompt will also be available in the description. Looking at it, the only thing you need to modify is the server URL, once the one we copied in the server setup section. Just add generate to the end of the link. Everything else remains unchanged. All settings stay the same. This prompt works very well for generating our client. Once Next.js has been successfully installed, we go to our chat, press enter, and then AI will start generating the frontend. The AI will analyze our project, check everything, and generate the full code. Once the AI has generated all the code, you need to make two modifications. First, create a new file in the root folder named server.js and copy the provided code into it. This code will be available on GitHub, so you just need to copy and paste it. Save the file. Second, modify the package.json file and update the start command. Instead of next start, we will start our server manually. This is necessary so that our project can be deployed on Railway.app as a standalone server. Now let's upload everything to GitHub. Once everything is ready, we move to GitHub. Here we create a new repo. This is very simple. Just click the plus icon and create a new repo. In our new repo, we copy and run the following commands in the terminal: git remote add origin, then git branch main, and git push update origin main. So these commands push all our code to GitHub. I won't do this now because I've already done it. My repo is named LLM. Now let's go to deploy the whole thing on Railway.app. We move to Railway.app now, and as you can see, I have already deployed my project. Deployment is actually very simple. Just click on create, connect to your GitHub, and select the right repo. In my case, like I said, it's LLM. After that, the deployment process starts actually automatically. Now let's do final step. Once the deployment is successfully completed, you will see a green check mark confirming everything is right. Here, you can see it here. Now go to settings, where you will find an option to create a domain. Click it and your custom domain will be generated. If you open the link, you will see your client application running. That's it. We managed to finish everything in 15 minutes and now everything is ready. Alright, now let's move on to the final test to see what we've built. Let's check how everything works by asking our model a question. For example, can I set up infrastructure in 15 minutes? Now let's send this request. What's happening now? Right now our request has been sent to the server. The server will process this request, which will take around 3 minutes. I know, you're probably surprised why it is taking so long. The reason is simple. We are running our model on a $1 per hour server. If we used 2, 3, 5 or even 10 per hour server, the processing time would be much faster. Based on my tests with our current setup, it takes about 3 minutes to get a response. But the most important thing here is to prove that everything works exactly as we planned and to show that it really is possible to build a fully working AI infrastructure in just 15 minutes. Now we wait for the AI's response. I want to tell you about why I choose a Railway app. While we wait, I want to quickly explain why I use Railway.app. The reason is simple. Many other hosting platforms limit request time to 30-60 seconds. That means if your server doesn't respond within that time, it automatically returns an error. With Railway.app, there is no such restriction. Also, you might have noticed that I used the Pro version of Railway.app, but you don't have to. You can simply sign up for the hobby version, which is completely free. It gives you $5 in free credits, which is more than enough for testing. And everything will work just as well as in my setup. I personally use Railway.app for other projects, which is why I had the Pro version. Now let's talk a bit about the frontend. Of course, our client doesn't look as polished as ChatGPT, but that wasn't the goal. The main point is that we built everything in just 15 minutes, and the client itself took around 5 minutes to generate. All the code is available in the description and on GitHub, so you can modify it as you wish to make the frontend look even better than OpenAI UI. OpenAI UI if you want. Again, the goal of this video was to show you a fully working AI infrastructure that you can deploy for just $1 per hour. You can download any model, host it on your local machine or storage, and have full access to it. You can load the model into your server, and in the end, your client will generate responses just like this one. And now response is here. Now let's look at what the AI has responded. Setting up infrastructure in just 15 minutes is highly unlikely and not recommended, especially for anything more than a very basic proof of concept. So what is it saying? Essentially, it tells us that the setup is not recommended for serious large-scale use. A more powerful AI infrastructure would take much longer to build. But again, our goal was never to create a system capable of handling millions of users. Instead, we wanted to show that a basic AI infrastructure can be built very quickly. Now, let's see what the AI says about what can actually be done in 15 minutes. What you can achieve in 15 minutes. Basic setup, you can quickly set up a simple environment using cloud services like Google and so on. We followed a slightly different approach, but still we managed to fully build and deploy this model in just 15 minutes. So what makes it different? In most other videos, people usually only show how to connect to an API and set requests. Every request costs money and they just explain how to process those requests. But in this video I showed you how to build your own infrastructure from scratch. If you increase your server's power, you could even offer your own API, meaning you could compete with ChatGPT. Of course, this model is not as powerful as ChatGPT 4, but you can see that the quality is decent. Looking at the frontend, we could also add audio input in just 5 minutes, I would say. We could also integrate a translator. This model understands English and Chinese well, but it struggles with other languages. By adding a translation layer, we could translate everything into English before sending requests and translate the response back into any language the user wants. This is just small improvements that can be added easily. So as conclusion, I can say the most important thing I wanted to show you that basic AI setup is completely possible in just 15 minutes. And I think we achieved that goal in this video. Well, as I say, the first attempt is always a bit rough, but I still hope it turned out pretty well and that you enjoyed this video. So I have a small request for you. If you like this video, which I really hope you did, please subscribe, hit the like button and leave a comment. Let me know what topics you'd like to hear about in future episodes and videos. Your feedback is really important to me and plays a big role in the growth of our channel. In future videos, we'll dive into topics like how to train models, the mathematical foundations behind them, and how AI models can be used in large enterprises, with a special look at concepts like smart cities. So, see you in the next videos, and until next time, bye.